children, my name is Mahalakshmi, working as CRTPS in Kgbv Tuni, East Godavari district. Hi children, how are you? All of you maintaining SMS, social distance, mask and sanitizer. Children, in previous session, we learned about the motion and its relative topic. That is, motion is relative, distance and displacement, scalar and vector, and also average speed and average velocity. So, in this session, we can learn remaining topics. Observe this picture. What do we observe is ants are moving in uniform motion and remaining animals in the forest are moving in different directions. From these two pictures, what we can learn? Uniform motion, non-uniform motion. So, in this session, we learn the topic about uniform motion and non-uniform motion and their relative topics. That are circular motion and acceleration. Children, note these keywords. Uniform motion, non-uniform motion, circular motion, acceleration and deceleration. Children, write the definitions. Children, recall the concept of speed and velocity.
Difference between speed and velocity. Speed refers to the distance covered by an object in unit time. Velocity refers to the displacement of the object in unit time. How fast something is moving is called speed. In which direction something is moving is called velocity. Speed is a scalar quantity, which measures magnitude only. As against this, velocity is a vector quantity which measures both magnitude and direction. Speed indicates the rapidity of the moving body. Velocity indicates the rapidity as well as position of the object. Speed is the rate of change of distance. Velocity is the rate of change of displacement. When the body will come to its initial position, its speed will not zero. When the body will come to its initial position, its velocity will be zero. As distance can never be negative, the speed too can never be negative. On the contrary, the displacement can be positive, negative or zero, The velocity can take any of the three values, depending on the point of reference. The formulae of average speed equals total distance traveled, time taken. The formula of average velocity equals displacement, time taken. That's all.
Children, now we can recall the great scientist Galileo. Great progress in understanding motion occurred when Galileo undertook his study of rolling balls on inclined planes. In the understanding the motion occurred, his study on rolling balls in the inclined plane. From this, we conduct an activity and observe this
uniform motion and non-uniform motion. There are always two types of motion. Uniform motion, non-uniform motion. You must have heard the story of hare and tortoise. We will take this story as an example to understand these two types. Let us understand and enjoy. Here, race between the hare and tortoise is about to start. The finishing line is 50 meters from the starting line. Now the race starts. The result is tortoise won the race. Now we observe this race in slow motion. We make a table like this, where we take distance covered by the hare and tortoise in every 5 minutes. Now we have the first table. Let us observe this carefully. From the data, we notice that the tortoise covers 5 meters in every 5 minutes. It covers the same distance in a particular time throughout its motion. This type of motion is known as uniform motion. We notice that the hair ray in its motion covers different distances in a particular time interval. This type of motion is known as non-uniform motion.
Uniform and non-uniform motion. Consider a moving vehicle or bicycle which covers a distance 5 meters in the first minute, 5 meters in the next minute, 5 meters in the third minute, and 5 meters in the fourth minute. In this case, the moving vehicle covers 5 meters each minute. As the object covers equal distances in equal intervals of time, it is said to be in uniform motion. Suppose a moving vehicle or bicycle covers a distance 5 meters in the first minute, 6 meters in the next minute, 5 meters in the third minute, and 4 meters in the fourth minute. In this case, the moving vehicle covers unequal distances each minute. As the object covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. If the direction of motion of the cyclist is assumed to be constant, then we conclude that velocity is constant. The motion of the body is said to be in uniform when its velocity is constant.
See this example. A man standing under a street lamp of height h above the ground starts running with a constant speed v in a constant direction. The light from the lamp falling on the man forms a shadow of him. Find the velocity with which the edge of the shadow of the man's head moves over the ground of his height is h. Observe the solution. Children, observe this activity, motion of a ball on an inclined plane. Set up an inclined plane. Take a ball. Push it from the bottom of the inclined plane with a speed so that it moves up. Observe the speed and motion of direction of the ball. Then what we observe? Now release the ball from the top of the inclined plane. Here, once again observe the speed and motion of direction of the ball. From this, what we observe? We observe that the speed of the ball increase gradually on the downward slope, but the direction of motion remains constant. Decreases gradually on the upward slope, but the direction of motion remains constant. From this activity, we learn that in the both cases, speed of the object will change on the inclined plane, but the direction of motion of the object remains constant.
Have you ever been on a skydiver ride in an amusement park? The ones where you sit on a swing and spin you around? If you have had that nauseating experience, then you know that the simple spinning on a circle can be very intense. This type of motion experienced on a skydiver ride is called as uniform circular motion. It is what occurs when anything moves along a circular path in a consistent way. If we want to study the motion of the planets, as well as a wide variety of earthbound objects, learning this type of motion is very important. Here are a few terms that we'll encounter later. For a better understanding of our topic, let us first define these terms. First, we have the word force. Force is just a push or pull of objects. Next is accelerate. It means to speed up. Then we have velocity. It is the speed of something in a given direction. Next is tangent. It is a straight line that touches but not intersecting a point at a curve.
Children, observe this example. Take an object which is tied to one end of a string. Try to rotate the string in horizontal direction as it makes a circle. Now draw its path of motion and velocity of vector at different points. Then observe the velocity of an object. From this, what we observe? We will observe that the object will be moving in a circular path with constant speed and the direction of velocity changes at every instant of time. So, finally we have learned that the direction of velocity at any point is given by the tangent to the circle at that point during circular motion. The direction of motion is therefore continuously changing, but the speed is constant. As we know that the direction of velocity is tangent to the path at a point of interest, so the velocity is not constant. In this activity, we learn that though speed remains constant, the velocity of the object changes continuously because magnitude of velocity is constant along the circular path. The only change in its velocity is due to the change in direction of motion. Children, observe another activity. Motion of an object thrown into air. Take a ball, throw it into the air while making some angle. Observe the speed and motion of direction of the ball. Then, what we observe? We observe that the speed of the ball decreases on upward slope and increases on the downward slope, and the direction of motion also changes continuously. Is what we learn from this activity. We learn that the speed and direction of the motion both changes simultaneously. From these activities, you can conclude that the change in velocity takes place in three ways. Speed changes with direction remains constant. Direction of motion changes with speed remaining constant, and both direction and speed changes simultaneously. See this example. Let the train starts from rest at station A. When it starts moving, its velocity increases, and after a certain time interval, it attains a constant velocity. As next station approaches, its velocity gradually decreases and finally becomes 0 at station B. The rate of change of velocity of an object is called acceleration. Here we can say that the term acceleration not only applies to increasing velocity but also decreasing velocity. The decrease in speed as the boat moves from initial position is called deceleration. Deceleration can also be called as a negative acceleration.
In a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you two examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved? None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity. Do you remember what velocity is? It's speed with direction and it's hence a vector quantity. Why is this important? Let's say a body moves from rest and reaches a velocity of 20 kilometers an hour in 5 seconds. Will acceleration be involved here? Yes, because the velocity is changing. It was 0 initially and at the end of 5 seconds, it's 20 kilometers per hour. In another scenario, assume that a body is moving at 30 kilometers an hour and then it moves right at 30 kilometers an hour and continues traveling at the same speed of 30 kilometers per hour. Will there be acceleration in this case? The answer is yes. As the direction is changing, the velocity will also change. The only thing constant in this example is speed, but the velocity changes as the direction changes. So this was the most important concept you had to know about acceleration.
Graphical representation of motion. Generally, newspapers and magazines use different types of graphs to present the information in an interesting way. They often use bar graph, pie charts and line graphs which provide greater details of the information and make the information more interesting. To describe the motion of an object, we can use line graphs. In this case, line graphs show dependence of one physical quantity such as distance or velocity or another quantity such as time. Now, we will discuss about the distance-time graph. To draw the distance-time graph for the given data, take a sheet of graph paper and draw two lines perpendicular to each other on it. Now mark the horizontal line as x0x'. It is known as the x-axis. Similarly, mark the vertical line y0y'. It is called the y-axis. The point of intersection of x0x' and y0y' is known as origin O. Decide the quantity to be shown along the x-axis and that to be shown along the y-axis. In this case, we take the time along the x-axis and the distance along the y-axis. Now choose a scale to represent the distance and another to represent the time on the graph. For the motion of the car, the scale could be x-axis 1 centimeter equal to 1 second and y-axis 1 centimeter equal to 5 meters. Mark values for the time and the distance on the respective axis according to the scale we have chosen. From the table, the set of values for time and distance are 0, 0, 1, 5, 2, 10, 3, 15, 4, 20, 5, 25, 6, 30, and 7, 35. The first number of the set represents time and the second number represents the corresponding distance. To mark the set of values 0, 0, look at 0 on the x-axis and 0 on the y-axis. This point is the origin. To mark a point for the set of values 1, 5, look for 1 on the x-axis and draw a line parallel to y-axis passing through this point. Look for 5 on the y-axis and draw a line parallel to x-axis passing through this point. The point of intersection gives the point that represents 1, 5. In the same way, mark the points corresponding to the different sets of values as shown in the image. Join all the points on the graph. It is a straight line which is the distance time graph for the motion of the car. If the distance time graph is a straight line, it indicates that the object is moving with a constant speed, that is uniform motion. However, if the speed of the object keeps changing, the graph can be of any shape, that is non-uniform motion. So, we can say that the distance time graph indicates the type of motion, whether it is uniform motion or non-uniform motion. Hence, we can conclude that the distance time graph gives information about the distance covered by an object in a definite time interval and also the distance covered by an object at any instant of time. Now let us know the procedure to calculate the speed using distance time graph. The distance time graph can also be used to find the speed of an object at any instant of time. To find the speed of an object, consider a small part AB of the distance time graph shown on the screen. Draw a line parallel to the x-axis from point A and another line parallel to the y-axis from point B. These two lines meet each other at point C to form a triangle ABC. Now on the graph, AC denotes the time interval T2 minus T1 while BC corresponds to the distance S2 minus S1. From the graph, it can be observed that in time interval T2 minus T1, the object traveled a distance equal to S2 minus S1. Then, the average speed of the car is S2 minus S1 by T2 minus T1. Speed gives the idea of how fast the body moves. In general, bodies move in a particular direction at an instant of interest, and this direction may not be constant throughout the journey. Here we will know about the velocity time graph. The change in the velocity of an object with time can be represented on the velocity time graph. In this graph, velocity is taken on the y-axis and time is taken on the x-axis. Case 1. For an object moving with uniform velocity, the graph will be a straight line parallel to the x-axis. This is because the velocity does not change with time.
We recall what we learned today's session. Keywords. Uniform motion definition. Non-uniform motion definition. Uniform and non-uniform acceleration. Circular motion definition. And deceleration. Worksheet. Worksheet. Roman 1. Match the following. Roman 2. Answer the following questions in 1 or 2 sentences. Roman 3. Answer the following questions by observing the table. Stay home, stay safe.